for chapter 1, today we will only cover this part. Okay, 1.1, elementary vector analysis. So the first part of elementary of vector analysis is the definition of scalar and vector. Scalar is a quantity that has magnitude. So what is magnitude? That is size or amount only. How much is the value? And then vector is a directed quantity, one with both magnitude and direction. So this is some of the example of scalar and vector. So we have mass, speed, distance, volume, time, temperature, and pressure. An example for vectors are weight, velocity, position, acceleration, and force. So look at this example. So what is the difference between mass and weight? So mass is a scalar, okay, only magnitude. So this is the amount of matter present a body. Okay. And what is weight? Weight is the amount of force that act on mass because of the pull of gravity. So we have this direction towards the earth because of the gravity. So this is a vector and this is a scalar. Another example, speed and velocity. So what is the difference between speed and velocity? Speed is how fast you are traveling, and the velocity is the speed in a given direction. For example, this car is traveling at the speed of 30 meter per second. This is speed. And for velocity, this car is traveling at a velocity of 30 meter per second east. Okay, it goes to the east direction. So this is a vector. Okay, velocity is a vector and speed is a scalar. Okay, next is how we represent a vector or how we write a vector. So let's say we have this vector O A. Okay, so this O, this is a initial point. The vector in 2D and 3D. This figure represents a vector in 2D. Okay, so you have x-axis and y-axis. Then you have, let's say this is vector u. This is point A and point B. So vector u is equal to vector AB is equal to 2, 3. Value is 2, 3. In this case, okay, this 2 is x component and 3 is the y component. So 2 and 3 is the component of vectors. You can also write in the array form like this 2, 3. Okay, next, and vector in 3D, we have vector P with 3 components, x, y, and z, 2, 3, and 5. So this is a vector in 3D. Okay, now the types of vector. So the first one here is the negative vector. So this is vector AB. You can see this is AB and this is CD. So a vector AB is the negative vector of CD if AB has same magnitude. Okay, they have same magnitude here as CD but opposite direction. So you can see here, these two vectors has the same magnitude but opposite direction. Vector AB is equal to negative CD, and AB and CD are negative vectors of each other. So the next part here is the equivalent vector. These two vectors are equivalent. Okay, this is vector R and vector S. So they have the same length and also same direction. They have same length and direction. Okay, now the magnitude or the length of vector. Okay, so let's say you have P, then the vector will be OP or vector P here, the component X, Y, and Z. So the magnitude or the length of the vector P is equal to X squared plus Y squared plus Z squared square root. So what if you have two vectors? If U is equal to U1, U2, U3, and V is equal to V1, V2, V3. Then magnitude of UV is defined as UV is equal to V1 minus U1 squared plus V2 minus U2 squared plus V3 minus U3 squared, then square root. Okay. So let's try example 1. Given vector A is equal to 1, negative 2, 4 and vector B is equal to 2, 3, 0. Find the magnitude of A, B and AB. So magnitude for A is equal to, magnitude A will be 1 squared plus negative 2 squared plus 4 squared is equal to 21 squared. And magnitude of B, 2 squared plus 3 squared plus 0, this is equal to 4 plus 9, 13 square root. And the last one, magnitude of AB is equal to 2 minus 1 squared plus 3 minus negative 2 squared plus 0 minus 4 squared square root. This is equal to 1 squared plus 5 squared plus negative 4 squared. Then you will get 1 plus 25 plus 16 is equal to 42 square root. So this is your answers. So next is the unit vector. Unit vector is a vector that have the same direction as a vector u but with magnitude 1. So unit vector you can write as a v hat. Okay, we call this as v hat. This represents vector u over magnitude vector u. So this is unit vector. Okay, where magnitude v hat is equal to 1. So let's say you have x and y. This is your x and this is your y. We have vector u here. This is vector u. Then this is your v. Okay, this is your v hat with magnitude 1. So unit vector is a vector that have the same direction as vector u but with magnitude 1. So this is your unit vector v hat. Okay, now let's try another example. Example 2. Find the unit vector of A. Negative 2 I plus 3 j plus k. Okay, so you have to find your v hat. Your v hat is equal to A divided by magnitude A. So this is your A, negative 2, 3, 1 and magnitude K will be, magnitude A will be negative 2 squared plus 3 squared plus 1 squared square root. This will be negative 2, 3, 1 divided by 4 plus 9 plus 1, 14 square root. So this is your unit vector. So you can check whether you got the right unit vector or not by finding the magnitude. The magnitude must be equal to 1. So magnitude we had negative 2 plus 3 over 14 square plus 1 over 40 square root square and square root. Okay, find the magnitude. So you will get 4 over 14 plus 9 over 14 plus 1 over 14 square root. So this is equal to 14 over 14, 1. So the answer for magnitude of unit vector A is 1. So now let's move to the operations of vector. So the first one is the vector equality. Two vectors are equal if and only if the corresponding components are equal. So you can say that vector A is equal to vector B. This is your A and this is your vector B. Vector A is equal to vector B is A1 is equal to B1, A2 is equal to B2 and A3 is equal to B3. Okay, the next part is the addition and subtraction of vectors. Addition of vector. Okay, let's say you have one vector here, vector A, and another vector. This is vector B. A and this is B. So the addition here, this is A plus B. So in this case, let A vector A is equal to A1, A2, A3, and vector B will be B1, B2, and B3. So that's how you get this formula. So similarly for subtraction, okay, let's say you have this vector A and this vector B. Vector negative B will be like this. So this is your A and this is your negative B. This is A minus B. So now let's move to multiplication of vectors by scalar. If alpha is a scalar, then alpha B, okay, you just multiply each of the component with this scalar alpha. Okay, multiply each of the component with the scalar. Okay, let's try this example. Given P and Q, okay, find P plus Q, P minus Q, okay, magnitude of vector P, and 2Q minus 10P. Okay, so you have your P 5, 1, negative 3, and your Q 4, negative 3, 2. Question number A, P plus Q, 5 plus 4, 1 minus 3, negative 3 plus 2. So you will get 9, negative 2, negative 1. And then B, P minus Q. So your answer is 1, 4, negative 5. Number C, magnitude of vector P. Magnitude of P, 5 squared plus 1 squared plus negative 3 squared, then square root, 325 plus 1 plus 9 square root, you will get 35 square root. And the last question, D, 2Q minus 10P. 2Q minus 10P. Okay, 2 times Q, 4, negative 3, 2 minus 10 times P, 8 minus 6, 4 minus 50, 10, negative 30, 8 minus 50, negative 6 minus 10, and 4 plus 30. So your answer will be negative 42, negative 16, 34. Okay, let's continue. Okay, next is the vector product. So in vector product, you have two types of product, which is the scalar product or the dot product. And another one is the vector product, or you can call it as a cross product. So when you do the dot product, your answer will be a scalar, and for cross product, your final answer will be a vector. So for dot product, let's say you have this A, vector A and vector B. For dot product, you just multiply the first component with the first component. Okay, A1 times B1 plus with A2 times B2. Second component and the second component, and then plus with the third component times the third component. And for the cross product, you have to do the determinant of 3 by 3. So this is I, J, K. And then just do the determinant again, I and J. And you can multiply each of that. So you will get this formula for the cross product. So there are some properties of dot product. Number one is the commutative. For dot product, it satisfies the commutative properties, which is u dot v is equal to v dot u. So if you do the dot product, the either way, you will get the same answer. Let's say A is equal to negative 5, 1, 3, and B is equal to 2, 4, 6. So A dot B is equal to negative 5 times 2 plus 1 times 4 plus 3 times 6. So this will be negative 10 plus 4 plus 18. So your answer will be 12. Okay, B dot A, similarly, 2 negative 5 plus 4 times 1 plus 6 times 3 negative 10 plus 4 plus 18. This is also 12. So it is commutative. A dot B is equal to B dot A. For property number 2, associative. Okay, look here. You have U dot V plus W. In order to solve this, you have to expand the bracket. Okay. So U dot V plus U dot W. And then number 3, magnitude. Okay, U dot U is equal to, okay, magnitude U squared. And for the dot product, you can find the angle between U and V. Okay, so this is the angle theta. So U dot V is equal to magnitude U times magnitude V times cos theta. So from this, you can get your theta angle. The last property, two vectors U and V are orthogonal or perpendicular if U dot V is equal to 0. Okay, so you know U and V, okay, it is perpendicular. So U dot V must be equal to 0. Okay, next is the properties of cross product. Okay, the first one is anti-commutative. It's opposite from the dot product. Just now it is commutative for dot product, but anti-commutative for cross product. So U cross V is equal to negative V cross U. And similarly for associative, when you have the bracket, you have to expand this. And for angle between U and V, you can find the angle by finding the magnitude of the cross product. Okay, magnitude of the cross product, U cross V is equal to magnitude U times magnitude V times with sine theta. And the last one, two vectors of U and V. Please correct this. This is a parallel. Okay. U cross V equal to 0. Then two vectors are parallel. Okay. U and V. U cross V must be equal to 0. Let's try one example of cross product. Okay, if U is equal to 2, negative 3, 1 and V is equal to negative 1, 3, 1. Compute U cross V. Okay, so the answer will be U cross V is equal to I J K, and your U will be 2, negative 3, 1 and your V will be negative 1, 3, 1. So you can just follow this formula here. You will get negative 3, 1 minus 3, 1 minus negative 2, 1, negative 1, 1. And the third component will be 2, 3 minus negative 1, negative 3. Okay. Simplify, you get negative 3 minus 3, negative 2 plus 1 and 6 minus 3. So negative 6, negative 3, 3. So this is your